boys and girls, we are going to review real quick over what we've already learned from the previous lessons, okay? And then we're going to start today's lesson. All right, of course, the first lesson was over integers, positive and negative integers, okay? And we talked about how they had to be whole numbers or zero to be called an integer. And then we moved on to the absolute value. Talked about the absolute value sign, and remember, I told you that all you're doing is deciding how many steps you are from zero. And you can't be negative steps from zero. So I told you if it was negative, you had to make it positive. You remember that with absolute value. Well, and then our third lesson was ordering and comparing integers, which was a pretty easy lesson, okay? And you know, I told you the further you are from zero on the negative side, the smaller. And the further you are on the positive side, the bigger you are, which you already knew that about positive numbers. And now today we're going to move into decimals and fractions. Now I'm going to be real honest with you. This is not really what I say a new lesson because I taught you decimals and fractions and how to change a decimal to a fraction or a fraction to a decimal last year in 5th grade. But we will review it, and they do take it up a step since it is 6th grade material. So I titled the lesson today, Decimals and Fractions. So we're going to start off with a new word that you've never heard before. And it is called rational numbers. Okay? That's going to be new. All right, like absolute value was new for you. Okay, rational numbers, we did not talk about rational numbers in the 5th grade. Okay, so let me give you the definition, then we'll go more into it. After I give you the definition of a rational number. It's any number that can be written as a fraction. All right, that's the definition. A rational number is any number that can be written as a fraction. Okay, now let me go into a little bit more detail on that, okay? What it includes. All right, that can be whole numbers, and I'm going to give you an example. Whole numbers, and you're probably thinking, how can a whole number be written as a fraction? But boys and girls, remember, you can put the whole number over 1. Remember, we did that in 5th grade. For instance, like if you have the number 8, you can make that to 8 over 1. Okay, well, that is a fraction. You have a numerator, you have a denominator. So whole numbers can be called rational numbers. Integers. You remember what integers are, right? Positive and negative whole numbers, right? Positive or negative, right? Whole numbers. Remember, those were integers, okay? That means like if you have, those are rational numbers. Like if you had a negative 7 or a positive 5. Those were called integers, and they are a rational number. Okay? All right. Oh, and don't forget, and 0. 0 was another one. Okay? All right. Then you've got decimal numbers. Decimal numbers. Okay? So decimal numbers, like 4.2. Okay? That's a decimal number. That is called a rational number. And then you also have mixed numbers. Mixed numbers can be called rational numbers. Y'all remember these? That's a mixed number if you have forgotten. So all of these are called rational numbers. Okay? Whether you have a whole number, because it's any number that can be written as a fraction. I can write a whole number as a fraction. I can write an integer as a fraction by putting that over 1. I can write a decimal number as a fraction. I can write a mixed number. Well, it has a fraction. So all of those are classified as a rational number. Okay? So that's something you do need to learn from this lesson. You need to be familiar with what a rational number is. Okay, so let's go back for just a minute and let's talk about how we change decimal numbers to fractions, because we did do that in 5th grade. So, for example, if you had 0.8, you know that that's 8 over 10, right? That's changing a decimal to a fraction. You already know how to do that. What if you had 45 hundredths? How would you write that? I bet you already said it. 45 over 100. And then if you had 0.329, how do you say that? 329 thousandths. So we're going to put 329 over 1,000. So that was changing the decimals to a fraction. And like I said, y'all are very familiar with that. That is not new. Okay, now let's review on how to change a fraction to a decimal. And y'all know how to do this too. Okay, so if you had 3 over 10, that says 3/10. How would we write that as a decimal? 0.3. Okay, what if we had 7 over 100? How would we write that as a decimal? 0.07. Okay, let's say that we had 16 over 1,000. How would we write that as a decimal? 0.016. Now, boys and girls, neither one of these are new to you. You learned this in 5th grade, okay? The part that I'm about to show you, we did some of it in 5th grade, but I'm going to show you a couple of different ways you can go about doing it, okay? So this is going to be kind of a little bit new for you. All right, so let's say that you have the fraction 9 over 12, and you're going, Miss Lane, I don't know how to write that as a decimal because that does not have a 10, 100, or 1,000 on the bottom. Okay, so here's how we're going to do it. Well, there's really 2 ways you can do this problem. You could try to reduce the fraction first if you like to reduce. Okay, it would make it easier on you if you reduce the fraction first, if it can be reduced. Well, I know on this one that it can. So I'm going to reduce it by 3. And I'm going to get the answer 3 over 4. Okay, so another way to say 9/12 is 3 over 4. All right, so here's what we're going to do. If we want to change this fraction to a decimal, I'm going to show you how this works. You could reduce it, or if you don't reduce it, you can still work it, and you're going to get the same answer. So I'm going to show you both ways. If I take this fraction, I'm going to say, and I know this is kind of new, I'm going to say, if I want to make it into a decimal, 9 divided by 12. So I'm going to go 9 divided by 12. Now, something you did learn in the 5th grade is you learned how to put a decimal and to put a 0 behind that. And you know that you can keep adding zeros behind that because I told you on the calculator that that's what happens. When you were sitting in my classroom, we talked about this, that you can keep adding zeros for as long as you want to. All right, so let's take a look at this. So, of course, you're going to bring your decimal up. Can 12 go into 9? No. Put an X. Can 12 go into 90? Yeah, but how many times? I think it's 7. And if I do 7 times 12, that's going to give me 84. I subtract it. I get 6. Well, I'm going to add another 0. Bring down the 0. Can 12 go into 60? Yes. How many times? 5. 5 times 12, 60. Subtract, you get 0. You just changed that fraction into a decimal number. So another way to say 9/12 is 75 hundredths. Now, let's say that you did not reduce. That is how you would work that problem. Now, the kids that like the reducing and want to make it a lot easier for them, they can reduce the fraction. And now what we're going to do, we're not going to say 9 divided by 12. We're going to say 3 divided by 4. So we're going to do 3, put a decimal, put a 0, bring up my decimal. Can't go in, goes in there 7 times, which is 28. You subtract, you get 2. A lot easier math here than this. Well, let's add another 0. How many times can 4 go into 20? 5 times. And look there. We got the same answer whether we reduced it or we didn't. The point I'm trying to make, though, is if you reduce it first, and it can be reduced, the math is going to be easier for you to solve. So what you just did is you wrote 9/12 as a decimal. by taking the numerator, dividing it by the denominator. Now again, you're going to have to add a decimal, and you're going to have to add some zeros. And you'll kind of know how many zeros that you need to add. You'll know that in later lessons that I go over. Okay? All right. So let's take another one. Let's try this one. Let's do 4 over 9. Now, if you take a look at that one, you know that cannot be reduced because the only thing that goes into 4 is 1, 2, and 4. And those don't go into 9. So we can't reduce it this time. So we just got to do it how it is. So we're going to do 4 divided by 9. Of course, add a decimal and add at least 1 0 to begin with. You probably will have to add more. Bring up the decimal. Can it go in? No. Can it go into 40? Yes. How many times? 4, which makes 36. Subtract. You get 4. Add another 0. Bring it down. How many times? 4. 4 times 9, 36. Subtract. 4 again. Do you notice what's happening here? Do you see what's happening? That's going to go in there 4 times, which is 36 again. And guess what, boys and girls? It's not going to stop. It's just going to keep going. Now, this is a little different, and this is new for you. If you notice, what digit keeps repeating? The 4. So when you write this, you don't need to just keep going and keep going and keep going. Here's how you're going to write this. When you've decided that the number is just going to keep repeating itself and it's never going to stop, here's how you're going to write your final answer, which this is new. You're going to put decimal 4 with a bar on top. The bar means that it just keeps going and it keeps going, kind of like the Energizer Bunny, okay? That bar means when I look at it that I know that the answer is really not just 0.4, the answer is 0.444444, and so on. That's what that bar means, is that number just keeps repeating itself, which is called a repeating decimal number, okay? That's what that's called. Now, I did not teach that in the 5th grade, so that is new. That is called a repeating decimal. Okay? This one, that is not a repeating decimal. It's 0.75. It doesn't keep going. It stops. So that is not a repeating decimal. You know what this is called? Terminating decimal. It stops. All right? It stops. It doesn't go on any further. So that's called a terminating decimal. It stops. I don't care how many zeros you add, your answer is still going to be 0.75. Okay. Let's see. Let's do one more. Okay, let's come over here. All right, so let's look at this one. Let's go 3 over 8. All right. Well, I know that cannot be reduced because 3 is a prime number. So I'm going to do 3 divided by 8. Of course, I'm going to add a decimal 0 to start off with. Bring up the decimal. Can't go in. Goes into 30 3 times. That's 24. Subtract. You get 6. Add a 0. How many times does 8 go into 60? 7. Let me erase this real quick. This is going to be in my way. 7 times 8, 56. Subtract. Get 4. Let's add another 0. Because I haven't seen anything happen yet. It hasn't stopped. It hasn't repeated itself. So let's keep going. That goes in there 5 times. 5 times 8 is 40. Uh-oh. Look what just happened. No remainder. And what did we get? 375 thousandths. So we just turned this 3 eighths into a decimal number, which is 375 thousandths. And this is a terminating decimal because if you notice, it stopped. It does not keep going. It does not repeat itself. You did not get a remainder. So it doesn't matter how many zeros you add. You're going to get 0, 0, 0, 0, 0. So it stopped. That's called a terminating decimal. Now, boys and girls, again, like I said, the main thing that you need to get out of this lesson is understanding what a rational number is and being able to change a fraction into a decimal when it does not have a 10, 100, or 1,000 on the bottom. And all you do is take the numerator and divide it by the denominator and add a decimal zero, and you may have to add several zeros. Miss Lane can't tell you how many zeros you'll have to add. You'll know as you keep dividing it. You'll know if the number repeats that you know, okay, I don't need to just keep adding zeros because I'm just getting the same thing over and over and over and over and over. And that's when you use the bar, okay, like in the other example. And in this one, you notice it stopped. So that's called a terminating decimal. You're going to know when you need to stop. Okay, so let's take a look at the guided practice that Miss Lane completed for you. Okay, so here it is. So right here, what I did is they wanted me to write them, the decimal numbers, as a fraction. So I did. I put 0.4 was 4 over 10. I reduced it. Okay, I'm not going to make you at this point, but I did. Then there was a 0.64, 64 over 100. I reduced it by 4, and I got that. Then the next one was 2 75/100. I wrote it, I reduced the fraction, and got 2 3/4. Then I came down here, and they said they wanted me to change these fractions into decimals. So that's exactly what I did. And you can look at this example and this example. You're going to notice these were both terminating. They stopped because I didn't get a remainder. They stopped. So my answer was 36/100 and 3 5/10. I was making sure I did that right. Okay, now look at this one for just a minute. You do notice there's a whole number in front. Folks, don't touch the whole number till the very end. What you're going to have to do is you're going to have to do the fractional part. 1 divided by 5. I did it. I got 0.2. Then I put the 3, the whole number, in front of it. So make sure you do that when you do your work. All right, let's take a look at the independent practice. On 1 through 4, you are going to write those decimals into fractions. If you want to reduce them, you can. If you don't, that's fine. Then on this bottom part, you got 77 over 200, 1 over 20, 12 over 75, and then 8 and 21 over 40. Here again, if you want to try to reduce them, you can. Of course, you can't reduce that one. If you don't want to reduce them and you just want to take the numerator divided by the denominator, that's fine. Just make sure you do put a decimal and put a 0 behind it, and you might have to put several zeros and keep dividing. And then here, don't forget, don't mess with the 8. Do 21 divided by 40, then put the 8 back in front of your answer after you get it. And that's it. So tune in for the next time I meet with y'all again, and it'll be lesson 5, and we'll just keep going on and do as many lessons that I can get completed for y'all, okay? All right, thanks.